Right, welcome to Wave 5. So today we are going to go over the homework. So probably it's the homework last week. Now you will get a taste. There are some of those real USACO contest problem. There are two of them there. And we're going to go through some of those as well as probably we'll spend half of the class to go over the homework. Then we'll learn a new topic called simulation. So today, I think we go through the homework in detail. There will be a good recap on what we have learned in terms of data structures and whether we can use those data structure we have learned in those homework problems. So the first problem is a sum of two values. Okay, that you given an integers in an array, and then you're trying to find two value in the array, and whose sum is the given number x. So this it is not a hard problem, right? So it's a simple math. So the most intuitive approach is just compare any two numbers in this array, see whether their sum is the given value x. So if you need to pick any two values, two distinct value from the array, so that if for those we learned in the number theory, right? So that's if the number integer is n, you choose 2, right? So the order doesn't matter. So it's a combination problem. So it's n choose 2. That means you need to do two loops. One is a loop is choose the first number, and then the second loop is to choose the second number. Right. So if you use a two loop, those are most intuitive solution. So you first reading the input, read this n, and then the sum, reading into your variable. Then you reading those n number, put them into an array. Then you do a two loop. One is one that the start and then end. Also use the start and end. This two position of the array, and then check whether their sum is equal to this given sum. And if it is, then you think the output they're asking you starting position is the first element is starting from 1, so we need to add 1 to the index. Right. But if so this is the most intuitive solution, right? If you finish this two loop and you have not find the solution, this return has not break out this, then you said it's impossible. You're getting to this, you have not returned yet. But if you, I don't know whether you have created an account on the, so I think I asked you to also create an account on this problem. This is CSES website, so which has a good amount of problem to practice. So you go ahead, create an account, and then for the problem, this is sum of two values, this problem, which I include a link on the homework. So you can, once you log in, create an account, you can click the submit button, and then you choose a file. So let's go ahead. I think I have the first version. This is some. Let me just make sure that the first version is the two loops solution. So the first version, yeah, is this two loop. Let's see whether we can pass all the tests in this. Right, we know it is not very efficient. Right, So you submit it, and then you automatically running all the test cases. So now you see some of the test cases have time limit exceeded, right? So that's often the case when you start with the most intuitive solution, but it is not very efficient. So you could run the test, and then they do have the limits, right? They mention in the test, say the time limit is 1 second. So some of those tests, this array could be very big. So the 1 second time limit is very short. It is exceeded. Right? Um, okay, oh, when I click this, then it's then that is gone. So that means this solution is not very efficient. And so what can we do? How can we improve this solution? Right. So first of all, when we read this in, right, we can check whether there is a simple check here as we read this solution. There could be a case impossible solution. What would be the scenario that we don't even need to come here to where we read through each number? We can check each number and make a conclusion. It jump to here directly is impossible. What do you think? What are the scenario that we don't need to go through this loop, that we can say this is an impossible solution? So we have n, we have the sun. As we read through this whole array, there will be a situation that we don't need to go through this loop. We can immediately say, after reading all those numbers, that this is impossible. Right? Remember the condition, they said there is no negative number. So you are all dealing with a positive number. All the array is 1 and above. So there is no negative number. What would be the situation that you cannot find any two number whose sum is this input sum? Right? Think about if every number you are reading is already greater than this sum, there is no way you can find another two number. If every number is already greater than this, or greater than or equal to, because they are all greater than 1. So if they are greater than or equal to this sum, there is no way you can find two number that is still equal to this sum, right? So as we read through each number, we can check whether are there any two numbers that less than the sum, right? If there are or just don't even need to count. Just say whether are there any number that is less than the sum. So we can add that condition first, so that we can get to this impossible. So that's one improvement. And then the second improvement, we have to deal with this two loop, right? When we start with the first number, right? If you look at this equation, they need to be in the sum. If we know the first number, and we know exactly the second number we are looking for, right? So once we pick a number, we can check whether the second number we are looking for, which is the sum minus the first number, we can check this. This is the number we are looking for. They are in the array or not. We don't need to go through this list. this each list. So when we pick a number, we still need to have the first loop. Well, first of all, we can talk about that later on. We can like filter out all the number in this array. If it's they are greater than some, we don't even need to consider them in this loop either. We should only consider those number that less than this sum. Right. So that's something we can make further improvement. But first, we have to use this first loop. But in the second loop, rather than go through every number in the second loop, starting from this number, we know what number we are looking for. We just calculate this number we are looking for, which is the sum minus the difference between the, and see that difference is in the list or not. How can we find quickly without searching the list, see whether it's in the list or not? Right? We can use what we learned last week, a data structure called set. Right? Set, it is a unique, or using a map. Things that we not just we need to know not just the number, but also its a position. Right? It's, knowing the number alone doesn't help. We need to know the index. So we need to have a map data structure. The key is the value of this number that we are looking for, and the value is the index, right? So that's in this second solution. So we build a map data structure, a map. So the first is the key, the second is the value, right? This map data structure, and we initialize to be empty, right? So the first loop, right? This is not indented correctly because the copy paste to this Excel. Let's look at the actual code. Right. So the first loop, first we if this number, the first loop, we pick a number from this array. But if this we only need to do this check if this number is less than the sum, right? If it's greater than, there is no need to check it, right? So if it's less than the sum, then we check the difference. I should do everything what is not doing the indent correctly. Right. Looks like missing and parentheses. Okay. So the difference is the first number with the sum. And then now we need to look for this diff number. Is it in the array? So we start with this map empty. So obviously we try to find this map is will be empty. So one way, there are two ways. If you guys remember the map data structure, there is two ways to check whether a number it is in a map or not. So you can use a map of find, right? Map of find, and then the number, whether it's a number which is it is in, you find it. If it's in the map, then it will return something other than this this empty. So if it's not equal to this n, then it means it's found, right? So this is using map find. Another method is using count. So you can count, see is this element it's in that or not. You do the count whether it's greater than 0. So if this count is greater than 0, that means you found this number in the map. So you're putting a value as a key to this map, you can either use the find. If you use the find, you check whether it's equal to this end function that give you return the end of this map. If it's not equal, that means it's found. If it's equal, that means it's not found. Right? Or you can use count. In terms of efficiency, this two methods is about the same. So you can feel free to use either one. So use count to find the key, whether it's in the map or not. If it's in the map, then we are done, right? We get our first number, and then the difference is in the map. Then together will make the sum. So then we are done. So that we get using the map, I get the value, right, of that index, and then this I plus 1 is the first number's index, right? This is the first rule, right? And then if it's not in there, then we go ahead add this number we are getting into this map. So this number is the key, and then this is the index. So we're adding 1 because the problem they asked us to use the index that start with a starting value of 1 rather than 0. So any those number index we add 1, but since I starting from 0. So any question on this map solution? Let's go ahead to submit this map solution. So some in version 2 is the map. Let me just double check yet. So it's automatically running through all the test cases. See, now it's not accepted. So we pass all the test cases. So there are two important things here. One is to check whether this is already greater than, right? This number we're getting need to be less than, otherwise there's no need to go through this checking. If it's less than, then we check whether there is another number already in the map. If not, we add this number into the map so that then it might be the next number will be. But if we find out the number, this number, put it into the first because that will be the number we have examined first, then put it into the map, right? So we can make a little further improvement, like I said earlier, right? We don't need to go through this for loop if we check every number is already greater than this sum. So let's look at the version 3. Yeah. So we start with, say, this problem before it said we adding a Boolean variable, impossible, that this is impossible. Okay. Made the font bigger. So it said this is impossible. And we read through the number into this array, then we check whether any number is less than this sum. If it is, then we go ahead to flip this flag, this Boolean impossible to be false, right? Since it has a number below this, then it's possible. Or we could probably do a count how many of them. I do a count, see whether we need to have a minimum of 2 less than that. Right? That's probably you can make that a little impossible. If there is only one number below, that's still impossible, right? You want to have a minimum of 2 numbers. So probably we can make that improvement as well. But at least if all numbers greater than this sum, and then it is, then we can check this Boolean variable If it's true, impossible is true, we just output impossible and then we return. Then else, then we go ahead using the same solution that we have done before using this map. Okay, we can go ahead to submit this solution. That's a version 2. Version 3. So we're adding the check. Okay. So if you look at the runtime, I think one of the earlier the runtime was a 0.15 second. Now it's down to 0.12 second. So just a minor improvement, just adding that check so that there are some certain test cases, very big test cases. They are all the numbers that are bigger than the sum. So we can go to the save that test case. Okay, let me look at one last version. Oh God, what was the? Okay, so another right improvement, right? Since this array, some of them they are greater than the sum, some of them are less than, right? We can filter them rather than go through all of them. We only need to look at those number less than this sum. So we can create a vector of index. So what are those number in this array? Their number is less than this sum. So only those number we need to go through the loop to check. Right? So we create a vector of integer to keep track the indexes of those number that less than this sum, right? So we do similar to the previous solution, right? We check this is impossible. And if it's less than, we go ahead, add this index I to this vector. Now, rather than go through every possible value in the original array, we only go through those value that less than this sum. So this index is the vector contain the list of numbers, their indexes that with their value that less than this sum. Right. So if do the filter, we go through each I, and then we still using similar method using the map, right? Checking the difference, then see whether this difference is already in the map. If it is, then we are done. If not, then we add this number into the map. So this is all again is just made this loop. If we compare this with previous version, right? This iterate to every possible number versus we only iterate to those number that has a potential solution, right? Those we know immediately those number we can ignore. We don't need to go through this checking. So we filter them, only keep the list of number in this vector that may have a potential solution. So let's go ahead to submit this solution. Okay, is also accepted. So in terms of the runtime, I think those two are very similar. I didn't say but you have to do side by side comparison which one. So those are more minor improvement if you have a case that have a lot of big numbers, they can filter out. So this will reduce that number that goes through the first list. Okay. So any question on this problem? So this exercise is a good use of this map. Okay. Oh, I forgot. I think the first, yeah, the second problem, right? We start with just the map. If you use just a map, data structure is an ordered map. So every element you insert into this map is sorted in ascending order based on the key value. So the first data type is the key, so it will be sorted. So obviously, when every time you insert an element, since you need to sort it, you need to know where to add that element. So internally, if it's using binary tree to store the data. We're going to learn the binary tree data structure later this semester. So it will take some additional time. So if you don't care about the order, so make a little minor improvement is to use this unordered map data structure. So unordered map, they just have the key and value pair. So key need to be unique, right? For you cannot have a duplicate keys, but the order doesn't matter. So this make this unordered map. The data structure is a little faster than the regular map, which is an ordered map. Okay. So when you don't need the order, so just using this unordered underscore map. So we learn unordered map, order map, and vector. Okay. So those are the exercise. This is the problem. I think is a good use of map. Other than map, I'm trying to see whether you can use a set and then and vector, right? Set to keep track the value of the array, but then you need to have another vector to keep track the index, right? So map, I just tied this two together, the key and value. If you're only using set, then you need to have another linear array to have the corresponding index, since we need to output the index. And if you're trying to use another tuple, even though pair and tuple, we can do a pair, right? But unfortunately, those won't be unique. And every time you're trying to get to see whether if you're using tuple pairs, whether a key is in the tuple or pair or not, right? You put that into an array of tuple or array of pair, then you still need to go through a search, which is more, I have to do a loop searching, see whether the value or not. So it doesn't have the this map or sets of find or count, all right? So this map, find and count, same if you're using set. So set has this find, right, whatever the value in the, as well as the set count. So trying to remember this two data structure when you need to keep track the unique value, right, whether they exist, and how to find out whether they are in the set or in the map using either find or count. So learn this two methods in your program in the future. Okay. Okay. Let's move on to the second problem. So the second problem, right, from the description, um, sounds very complicated. So they trying to create a story, and then you need to read the description of the problem and then translate it into a program that you can write, right? So essentially, for this problem, it is a string, right, giving you an input, a string, how many character of string, and and you look for what is the largest substring of the original string that has a duplicated pattern, right? You're looking for a substring that in the original string that has a duplicated pattern, right? You want to find the longest substring. So how do we solve this problem, right? That probably first thing, right, you need to read through the input, right? Input give you two input. One is the number of character or number of mailboxes that Farmer Jones walked through the road to look at his house, look at the color of the mailboxes. And this is color of mailboxes, it's represented by a string of alphabets. And the problem want to read through the translator to what the problem is looking for, right? It's basically looking for k minus one substring. They are duplicated in the original string, and actually find not the minimum, so find the maximum k the substring that k minus one substring duplicated, right? And then k substring, then in the original string, then it's unique, right? So it's not repeated in the original string. So not the minimum rather than maximum. No, actually, it is a minimum. It is correct. So the minimum value of k that that k substring is unique, which is correct. So this is statement. This is still correct. This is a minimum. Right. So the reason is the minimum, right? If the original is n, if I find maximum, then it's always n, right? And then it's unique to the original. So you want to find out number, the k that the k number of character in the original string. There's no way you can find that it is duplicated. Then it becomes unique. So the first thing that we need to do, it is for the original string that any length of substring, whether we need to check whether the original string contain multiple of the substring. Right? So for any given length of the original string, then we want to see whether there is any duplicated pattern contained in the original string. So we can use a set, right? A set, it is a good data structure to check whether it's a duplicate or not. So every time you encounter checking duplicate, so set and map other two data structure, you immediately come into mind. If you don't need to have a key value pair, then you don't need map. Right? Set alone should be sufficient. If you also need to have a key value pair, then you need to have a map. Right? So we can get any length, or given this a length of a substring, then for the original string has n, right? Then the starting value is starting from I all the way to the starting value I minus this length. That will be the last starting value to get this substring with a length of len length, right? So we need to stop here as the beginning of the substring. And then in C++, and then this is actually is a C function, a string dot sub str. This is a substring getting from the original string, you're getting a substring. The I is the starting position, and then this is the length, how many character you want from this substring, right? So we change the starting value I, that's how many possible substring we can get from this first for loop. Now we're getting that many in this for loop number of substring of length is len, right? And then for each of this substring, we use this set underscore sub, where we define here, which is the data type is a string. We check whether now you see this we're using this count. As I said earlier, you can either using count or find function to check whether it exists in the set. We count if it's in the set, that means it's already one subset in this set. Now we're getting another subset. That means they are duplicated. Then we return true. But we're getting two subsets, and they both are in there. If not, then we insert this into the subset. Any question on this check duplicate? Okay, so then in the main function, first, actually the first we can, the one that from now on, there is something easier to, in terms of the F string reading, so we can consolidate this two line directly, rather than creating different, just put this value, this file name directly into this parenthesis. So from now on, in the future, you encounter any USACO's older problem, the first field line to be exactly like this. So we can get rid of this two. So we save two variables. So this is the input, this is the output. So just use the if string, and then this f in and f out. Then we can use the f in and f out just like our c in and c out. So whenever you need to read input, right, read from this file, you do the f in. If you need to write it out to the output, f out. So next time, like just those older USACO problem, they read it from a file, write into a file. So you can use this code, sample code to as the first field line. Okay, let's make this a big. So we read it Okay, this is still not using, doesn't matter. Let's fix this later. Read the input into N and S. Then we can check starting this is sub string length starting from 1, and then we can stop at half of the original string, right? There is no way the substring that more than half of this, they still can have a duplicate, right? So we can stop at a half, and then we increase the value. And then for each of this length, then we check whether there is any duplicate substring of this length. So if a duplicate, then we keep going, right? So if a remember this is check duplicate. It will return true if there is a duplicate. We're starting from 1, so we find the single character duplicate, then we keep going, right? If only when this is not, then we stop it, right? So when it's a not duplicate, when we get into the substring, we cannot find a duplicate, then we stop. So any question on this solution? So this is substring length is the one that's the K that we are looking for the minimum value. Okay. So when we get into this substring length, we use this our check duplicate function. We cannot find any two substring they are identical in the original string. Right? And the second solution, rather than going from the starting from a single character of substring, like going to all the way to half of length, we can do the descending order, right? So we check the substring from the descending order. Fix before I forget that. So the first case is the ascending order from small to large. Then the second case, we can start from the largest, from largest possible substring to the smallest. So we do a descending order. Now we use the same check duplicate, but now instead of check not duplicate, we check if it is duplicate, since we're starting from the largest. If a duplicate, then we stop, because that we found the first largest substring that has a duplicate, right? Then this duplicated substring plus 1 is the one, the K, that is unique, that is not duplicate. So you see this problem, we are using the check duplicate instead compared to the previous one, and then this one we adding 1. So there is a minor difference, right? This when we do the ascending order, we checking is not duplicate, then we stop. Versus here, when it's duplicate, then we stop, right? And then when it's duplicate, we stop, and then we add 1 to this sublength, so that sublength as 1, it is not duplicated. Okay. And similarly, we can think we use this set to check whether there is any duplicate, right? We could use a map to check a duplicate as well. This is check a duplicate. It is using this string, and the integer is just getting this exists in there. We just assign it into 1, right? So this value probably doesn't matter that much. It's a map. Since the one that this account, we actually checking this account, this key is in that or not, right? So we are not using this value. We are just using this key. So we insert this key into this map whenever there is a not found, right? This is not in there. We insert this key into this map. So they are very similar to the set, and they are the remaining, the main functions logic is identical, right? So if we are doing, this is actually descending, not, right? So this is a descending order from largest to smallest. The a map is not going to be better than set, or since we are not using the value, just using the key. So, but in terms of performance, in terms of um, the big O notation, they are the same range, right? Right. So all those they are all in sense of we only checking half of the n, then each of them we go through the n. So it is um, this n square. So even though we're doing half n. Any question on this second problem? Let's take a 10-minute break before we come back to the third problem. Okay, hope everyone is back. So can everyone turn on your camera so they know you are back? So we will continue to problem number 3. Sorry, I will speed up a little since we need to cover a simulation as well. Right. But this problem, it is a US open contest. So it is, so everyone know how to play tic-tac-toe. It is a game on the 3x3 box, and you put an X and then an O, right? That's a normal tic-tac-toe game. So in this 9 boxes, so this team tic-tac-toe is in addition to the individual one, you can also have 2 players team up together to win the game. And they put in this story about the cows. They're playing this game, and then you could have multiple cows play in this game. You don't know how many of them play in this game. You can up to, since this has 9 players, you could have up to 9 cows play there. Each of them played once. That could be, so start, it could be from minimum of, you need to have minimum of 2, right? 2 all the way to 9. So you don't know how many of them play. And you just read this outcome. You want to check whether there is any single cow wins this game. And the second output, so the first output is the number of single cow wins this tic-tac-toe. And then the second line is the input, how many teams that win this game, right? The team, it could be, in this example, it could be X and O, right? There's 2X and an O. If X and O team up together, they win this game. But if C and X also team up, all right, this diagonal C, X, C, if they team up, so that also win the game. So there are 2 possible teams to win this game. So that's the output 2. So how do we write a program to solve this problem? So obviously we need to write a program to check whether there is any single cow win this problem. So write a separate function just to check a single cow wins the game. And then write another function to check whether there are any 2 cows that win this game and how many of them. You need to count them, right? So when you check, you need to check 3 rows, 3 columns, and 2 diagonals. So there are 9 arrays, 9 of 3 elements, right? So you need to check 9 of them. Oh no, 8 of them. 3 rows, 3 columns plus 2 diagonal, 8 of them. Okay, so we do this, read this input 3x3 characters, and you need to check 3 rows, 3 columns, 2 diagonals with a single cow win by itself, and then you need to check any combination of 2 cows can win as a team. So the first function is that you check individual win, right? So there are, so you check the diagonal, and then, so this is 2 diagonal. So this, well, first we put this this board, 3x3 board, as a global variable. So we assume this read into this 3x3 2 dimensional array, so we put this as a character two-dimensional array, 3 by 3. So store that as your input. Then you check for any cow or any character ch, any character, whether this right diagonal, so 0 0 is the first element, right? This 1 1 is the one in the middle, 2 2 is the one on the bottom right. Right, so that's the diagonal, and then the other diagonal is from the, this is from the top right to the middle, then this is to the bottom left. Right, so they are all equal to this cow's character. And if either this diagonal true, you just return 1. Then you check the rows, right? Rows, they just I is the one, the number is, so you just iterate when it's 0. So this is, so this is actually, this is a column, right? So this first rows I element, second rows I element, third rows I element. So that's the first column. This is checking the column, right? As I changes from 0 to 2, the first column, second column, third column. And then there's the second line, I here is the row. Okay? So when it's 0 0 0, this is the first row, then 0 1, then 0 2. So we have put this in a loop so we can check the row and column. Okay, this is not that complicated to check the individual. Now, how do we check the team? But before we check the team, we can do this comparison. Right? You given 2 character and 3 character on the board, whether it is a row or column or diagonal, it doesn't matter. You check whether there is any duplicate. You check whether there's a 2 character that have a duplicate, right? If you none of this, right? So the A is not in this 2 character, then you return false. Or you check B if it's not. So as long as the one of them, so you check all of them, they're not in this 2 character, then you return false. Until you go through everyone, then you return true. That means there is this 2 character, they are in this A, B, and C. So at least 2 of them in there. Then this is checking whether they at least appear once, right? If they have appeared once. If 3 of them they do not exist, then you return false as well. So this is more using the not equal. I think you can write this logic as using equal as well, right? Using equal, you check whether there is any this ABC, right, can only form by this 2 characters. So one of them is duplicate. So you can do it that way too. Okay, so once you have that logic to check whether each row or column or diagonal that can make up using this 2 character, so you check 2. So this is the diagonal, right? This is another diagonal using this 2 character. Then can make up that is, if this is true, that means it's a team win. So you return 1. Right, then you check the row for this 2 cows as a team. If using this check 2 function, any of them is true, then you return 1. Otherwise, you go through all of those 8 check they are not a 1, then you return 0. So this two cows as a team didn't win when you return 0. Then you put them together. Right? The first thing I said we do this. Let's use the code easier to read. Tic-tac-toe, tic-tac-toe, this one. And in the main function, we read the input and then set up the output. And then using this set, actually this is already improved. So the reason I'm using this set to rather than iterate through A to Z, 26 of them, we just using this set, see how many distinct cards play in this game. So when we read through each of them, just insert this value into this set. So this cards set get a list of unique cards that play in this game. Right? Then we just for each card in this set, we go through this loop. So each card in this loop, we call this check individual win, right? We're getting this card's character from the set. And if there is win, we record it. So remember this return as 1. So we starting answer 1, individual and 0, we just record. There could be multiple cards wins possible, right? So we go through every possible cards that play this game, check the individual win. Then we go through this card, we get 2 players. So when you get 2 cards, we need to be careful whether we don't get duplicated, right? So the first one, so this is a little advanced. We're using the iterator. So iterator member. So this we just call it auto. So this data structure is a little complicated, so you don't need to know. Just call it auto, and then this is set the begin, and then not equal end will be the next the ending. Then you increment. Right. Remember, in the set, we cannot use like an array doing the index, right? So we cannot set a 0, 1. We cannot do the increment like that. So you have to increment with a begin and end. So those data structure, if you remember that we said there are some data structure that are linear versus those that are nonlinear, like set and map, those are the data structure nonlinear. So we cannot use the index of each element. We have to use the begin and end and then do an increment. So we get the first player from the list cards, our first player, and then the second player, we go starting from this, so we don't want to duplicate the iterator 2, so get to the next element in this list. So this next function, it is the function that will go to the next element. So remember, this is a data structure. We cannot just say +1, right? If iterator 1 plus 1, you will get a syntax error. But this plus plus is okay. Plus plus, it is they have provide that the operators for this data structure, for the iterator data structure, they have defined this plus plus operator to go to the next. So this plus plus is the same as using this next. But we don't want to have a plus plus here. If we plus plus, then we're going to change this iterator one's value. We don't want to change the iterator's one's value. We just want to get the next value after this iterator one. So we use this next, get that value assigned to iterator two. So this is the first call, this is the second call, and then we put both call into. So remember this iterator, when you use an asterisk. So iterator, it is a pointer. It is a data structure with a pointer. You use an asterisk to get its value. So asterisk is getting the value. So that's the character that we check the team win. And if we get it the team win, then we record this answer to the number of team win. So this is probably it's, a little complicated, but it's a good learning to how to iterate through a set data structure, right? So you cannot use for I and then increment I and then using the I as an index like an array. For the set and map, you have to use the begin and end using this iterator and then increment to go to the next. Or there is another way to do this if you want to just do element, right? You can do do the element or just do a cow in this cow. So if we only want to do this first one, right? But the issue with this, right? This will be getting the first one. But how do we get the second one that is different from this? So we cannot do this. Say so this first cow. Say first cow. We do second cow. And if you do it like this, right? Doing this as a two loop, but you adding say the if C1 equal to C2, then you skip. So unfortunately, this doesn't work either, right? Because you oftentimes get into the duplicate, you might get conflict to each other. So you need to use this iterator so that to starting from one after the first one, right? So this is if it is in array data structure, when you have a two loop array, right? You use an I for the first one, then you use a J, then it's J is become I plus one, so that it won't get duplicated. If this is a linear, then you do it like that, all right? The first loop you start from I from 0 all the way to the end. Then the second element you want to have a different, you start from the next value after I, you plus one. So unfortunately, this map, you cannot do this plus one. You have to use this next. So that's the equivalent when they are linear. You use the I and J doing two loop. That's how you do it in two loop. Okay. Okay. So that's the solution. Let's go ahead to submit this solution on the USACO's website. So has everyone created an account, not just on the training, right? I know last time we asked everyone to create an account on the training, USACO training, but on the regular USACO.org, you should create an account here as well. So I don't know why they have a two different account system, but this you can create an account as well. And then once you create an account, those old problem you will see this on the bottom that you can submit your file and then submit the solution. Then you can check your solution. So the one that this team tic-tac-toe. So this, right? So let's go ahead, submit our first version. So make sure that you select C++17. So you will go through compiling and then run through all the test cases. So you see though, when it said start, that means you pass the test case. It gives you the amount of memory you use, so 3.3 MB, and then the time, the runtime you use. So 3 ms is the millisecond, the millisecond. Right? So we pass all those 10 test cases. When you see the star, that means that we pass those test cases. If you see an X, then you failed on that test case. Okay. Any question on this solution? So this solution is checking this like using not equal. It's kind of counterintuitive, right? We can just check whether there is any duplicate, right? If you check 3 character, right, whether it's a row or as long as you have any duplicate character, then it is a team win, right? If you have just a duplicate value, then it's a team win. If there's 3 of them, they are all distinct, then there is no team win, right? So you can just write a code, just check the duplicate. So it's the second version that we just check the duplicate, right? Even those 3 character, those 8 array that we need to check, right? Those in the 3 row, 3 column plus 2 diagonal, those 8 array, we need to check those 3 character. So we check whether there is any duplicate. There are 2 duplicate. We first check whether they are all identical. So you check whether C1 equal to C2 or C1 equal to C3 or C3 equal to C2 equal to C. Right? Those are the 3 cases that you can have a duplicate. But when you have under this, they are duplicate, we also want to exclude the case that they are all identical, right? C1, C2, they are all identical, right? In C++, you check 3 variables, they're all identical. You have to do 2 pairs, right? You check C1 equal to C2, then C2 equal to C, or you can do C1 equal to C3. Right? But you have to use an AND condition like that. You cannot just say this is 3 C1 equal to C2, then equal to C6. So we want to exclude, this is the individual wins situation, right? We want to say this is a false. If it's not this individual wins case, then this is a team wins situation, then we return true. Then if it's not, we'll return false. You see, this logic is much simpler than say this if or not. This is kind of hard to understand, right? Versus this logic is much simpler. You're just checking, see whether there is any of the 3, any 2 of them are this identical, right? And once you have this logic, and by the way, you don't need to, since this entire list is just a 3 character, you don't need to have a set, right? Normally, we check a duplicate using set, but if you're using set, that's kind of overkill, right? If you have a array that's really big, you want to check out whether you have duplicate, then you should use a set. But for this problem, just a list of each of elements. There's not that many. Okay. once you have this, then we can do this, what's called, um, okay, I'll come back this tuple get team name back later on, right? So when you trying to count the team wins, right? So you just feed each of those eight situation. This is diagonal. You call this a check duplicate, right? And if it is true, then you insert into this team that with this two character, right? So we don't know which two character make which one is. We go ahead to getting those three character in that, and then getting this team name. It is trying to get the unique, well, which out of those three, which one is a duplicate? We need to remove that duplicate just to get the one that two character to represent this as a team, right? So out of those three character, the two of them are duplicate. Then we using this set. So we put this three value into this set. Then it will give us this set, right? Since the set, remember the data structure doesn't allow duplicated value. So only two character will be remaining in this set. Then we go ahead to get the first and the next one, the value. So this is returned as a tuple, or we can use a pair since this is two, or we can use a pair. But it's just trying to use a tuple that you can return two value, right? Put two value in this braces. So you as a you if you have a multiple, you can do the comma as a multiple. Put that into this braces, and then this value become a tuple or whatever. So this braces can more a universal combination of the value. It could be an array, could be an tuple, could be a pair, could be a lot of the data structure. You can using this to pass as a return value. And so the purpose of this get team names function, there are three character and two of them are duplicate. We want to remove the duplicate just to get two character as a team name. So we get that, then we insert this as a team. So now this team is a two character. So it's a tuple of two character, which this function, the return, right? Return this two character of the team name we insert into this set, so that the reason we want to insert this into a set so that you could have a multiple the duplicated count, right? This team, right? If it exists in multiple rows, I think the question is asking you to how many teams win, right? It's not how many times. It's not asking how many times they win. It's as long as it's kind of how many distinct teams win. So we putting this in a set to eliminate the duplicate count. Okay? So we insert this team name, right? If it is say this is a AB, and then there's getting an AB again, then we insert that. Then only one AB remaining in this teams win the list, right? So we go through this diagonal, this row and column. Then when we are done with checking those eight array, then we are done, right? We just this team's size, but this is actually for debugging purpose. We don't have to do this, right? So this is more for for debugging purpose, we want to see what are the lists of the team that won. We can comment this out. Go ahead. And then just return the team's size. I remember in the set data structure, if all you care is how many elements in the set, you're just using this size function, which is what we need, right? So we check the individual win. So the main function, once you have written that, then this main function is very simple. You first check the individual win for each of the cow in this, the playing this. So I remember we use this set to insert this so that I have a list of cows in the playing this game. So we go through each of the player and record the individual win, then record the team win. Okay, so we can go ahead to submit this version as well. So we choose this is version 2. Actually want to do a comparison. So this is they are all 3 milliseconds. So this one is 11 millisecond, right? 11 millisecond. So we want to. So there is in terms of efficiency, this is 2 version. If we go back to the first version, efficiency wise, not much difference except just make this logic is simpler, right? Easier to understand rather than this is or using the not equal, right? So it's a little unnatural. You want to check whether there's any duplicate rather than checking the not equal. And then I think and then this is using this for loop doing the versus this one. It's just directly to check the team win. So we don't actually need to that for loop. So it does improve a little. See, we are not doing the 2 loop. See, we're only doing the 1 loop, right? So we are only doing this 8 array and check each array whether there is any team win. Then we add them up. So this should be a little efficient. So we go ahead to open another window. So this is the first version. Yeah, this is the first version, and this is second version. It's run the. Make sure that selected C++17. Submit the solution. Okay, so the kind of those test cases, so probably we can't tell which one is more efficient than the other. So was 15. This is probably just a random times error, though they're all in the millisecond, right? So they are in the same range of efficiencies. So any questions on the homework, those 3 problems? I think this probably the second problem is the most difficult if you have not come up with what is asking for is checking the sub-array duplicate. And so the third problem should be in terms of logically is simpler, right? Since everyone knows how to play tic-tac-toe. So that game is well understood. The only complication is just adding a team that you just need to check the case. But those exercises help to practice some of those data structure we have learned. Okay, we have about 15 minutes left. So the good news is the content we need to learn today is very short. So it's just the method that we need to encounter certain type of problem that you need to do a simulation to simulate all the cases to what happened, and then do the add up all the cases or do an average or whatever, right? That's what is called a simulation. So you have if there are 100 scenario, you do each scenario, record the result, then you go to the next scenario. So each scenario, they have a different initial value, right? You change the initial value, then you do the go through the step, calculate the result, then record the outcome. So that's what is simulation. And oftentimes you do sometimes you do simulation, the initial value, you set the random value. So that's what typically what you call the Monte Carlo simulation. You set the random value so that you will have a different under this random condition, then you have go through the process calculation, then you record this outcome. Right? So this is a case when there is no algorithm that you can directly to calculate. You can only use a simulation to solve the problem. So let's look at one very typical problem. And so this is 4 years ago. This is 2019 USACO's problem. So it's called a shell game. So probably you know those. This is actually just like you have 3 cups, right? You putting a chips in one of the cup, and then you cover it. You don't, and you first play. You let the other player to see where the chip is. And then you put the cup covered it. Then you swap, move around the cup, see whether that player can watch how you swap it, and then yes, so which cup has the chip, right? This is exactly that game. So even though we have a lot of description, so it's like Betsy, and then it's the cow and her friend Elsa who play the version of the game they saw in the county fair. So they instead of using cup, they're using a shell, using shells put on the table, and then cover. There's a pebble. Like pebble is like using a chip. You use shells to cover a pebble. So you only have one pebble. You're putting those three shells cover the one pebble, and then you let the other player see where the shell is. You cover. Then you swap the shells, and then each time so this game, each time you swap, you let the other player to take a guess, and then whether it guesses correctly, you record it. If it gets correctly, you record 1. If it's wrong, you record 0. So you do this many times, and then it asks you what's the maximum number of a point the other player they have guessed correctly. Right. So basically, what this problem is. So the sample input is a 3. This first number is how many times they have done this swap and guessing. So you start from the 3 shells or 3 cups at the position 1, 2, 3, right? 1, 2, 3. So then the next 2 number indicate the index, the first shell, and then this second shell, this Betsy. make a swap. So she swapped between 1 and 2. So that's what it means. And then this 1, the next number means this uh, Elsie, making a guess. The pebble is still in shell number 1 after this swap. So it's remaining in position number 1. So you making the swap. This guessing is just this 1 or 2 the position on the table. Right. Then this next 3 number is the next play. So this 3 and 2, that means Betsy make a swap between shell number 3 and shell number 2. And then Elsie still made a guess. Let's say the pebble is still in shell number 1. So that this is the second set of 3 number. And then the last set 3 number is 1 and 3. That means Betsy make a swap between 1 and third shell. And then Elsie still making the guess. Let's say the pebble is in shell number 1. So after this is being played, then this sample output, it is asking you. So even though you don't know initially which of those 3 shells that has the pebble, it's asking you on regardless to which one, right? The starting with playing this 3 times. This is the swap. Those are the sequence of swap, and then this is the cup that she gets, right? What's the maximum value she can get, right? So that means you need to evaluate initially the shell, the pebble is in the first shell, and then you play through this again, and then record the value. And then you do this again, then put the pebble in the second shell, play this again, and then record the value. Then the last scenario will be you put the shell on shell number 3, play this swap and then guessing, and then record the outcome. What's the value? So all of those 3, see which one is the maximum, is the outcome. Does everyone follow this? What is asking for this problem? Okay, how do we write a program for this to solve this problem? Right. So we can just simulate this process. All right, we start with an initial position. Right, there are 3 shells. There are 3 possible positions. The initial position, right? And this pebble could be on shell number 1, could be on shell number 2, could be on shell number 3, right? Those are the 3 initial positions. Then you go through those swapping and guessing, and then you record the win and loss. Then you go back to this, change this initial position, then play this game and record the result. Once you do this 3 times, that exhausts all 3 possible scenarios that you have simulated. Right? Under this 3 scenario, what are the scores for each of the scenarios? Then you count the maximum value. Does it make sense to everyone? All right. So let's look at the code. How do we write the code for this problem? So this shell in is just like that example, right? So play this 3 times. So 1, 2 is the first two number is doing a swap between shell number 1 and shell number 2, and the other players guessing. Do that. The guessing the pebble is on shell number 1, then the second you to swap between shell number 3 and shell number 2, then skill guessing number 1. And the third, you do a swap between number 1 and number 3, and she's still guessing number 1, right? So that's the input. Now, the first thing, right, we read the input and then we prepare the output. So the first number is reading how many times they play this game, right? The first number is 3. It's how many times? So this is 1 time, 2 times, and then 3 times, right? Okay, how many times they played it, and we need to use a 3 by 3 or this a 2-dimensional array to store the value, right? So the initial value could be this pebble. 1 indicate the pebble is on which shell, right? In the first position is the first shell, and it's 0 on the second. So it's on the first, then it will be 0 on the other. And then this is another scenario that is on the second shell, right? This is the last one is on the third shell. So those are the 3 scenarios. So we need to store those 3 scenarios in a 2-dimensional array, the 3 by 3 matrix. Right? Then we create a counter, right? Counter is just using an array, and each of the scenario, what's the score for that scenario? So we use this counter to record the score, right? So then this A, B are the shell's index that are taking a swap between A and B, right? G is the shell's index that guessing that has the pebble, right? So we go through this, how many times we play, right? This N is the number of times we start. Then each time we reading those 3 numbers, the A and B, the number doing the swap, and then the number doing the guess. And then when we read it, we need to decrease by 1 because our index all starting from 0 versus the number in the input is starting at 1. So we subtract 1 from the number we have read. Then we go through this 3 scenario, right? So under each step of doing the play, we go through each scenario. J is the scenario, those are 3 initial position. So we do a swap. So just we look at this mind swap later on. So mind swap is just a swap 2 number, and then we use this %, just getting the address of this 2. So this is A and B, right? This is A and B, and this is J is for each scenario, right? Remember when we say for J is 0, right? It's basically this, right? 1, 0, 0. If 1, 0, 0, say if you remember the first one, A, B is 1 and 2, right? So 1 and 2, A is 1, right? We will subtract this will become 0 and 1. So we swap them. So originally 1 is here, then 1 will be here, this will be 0, right? We swap this 1 with a 0. Right, so this is my swap. That's what it does, right? If you go look at this function, so my swap is just getting two variable a and b as a pointer. The reason we want to use a pointer is because this is stored in the origin. It is in the array, right? If you just make a copy, change the value, it doesn't change this array's value. We want to change this array's value, right? Change the array to change this array's value. You're getting the address. You're getting the address, and then this address, you using an asterisk, then do an assignment. That's where they change the value. So we need to use a temper variable. So unfortunately, C++ doesn't have like this. It doesn't so in Python, you can do this, right? You can do the two variable assignment, just A equal to B, then B equal to A. You don't need to do use a third variable. So this you can do in Python. Unfortunately, you cannot do this in C++. C++ doesn't allow two variable assignment. So you have to do one variable assignment at a time. So we need to have a temporary variable, right? This just store the value of this address. Remember, using an asterisk is getting the value of that address, right? Now we need to change the value of that address. Then we use asterisk of this variable. Then we set the B to A and then B equal to temp, right? Because this A's value already changed. We want the original A's value. So once you do this assignment, A's value is being changed to B. You want to get the original A's value. That's why we need to have this temp variable. We get the temp, which is the original A's value. So that's what this swap. And we swap this two. So this is, we read this A and B. Those are the index that we need to swap, right? We do this J many times for each of the scenario, right? Each of the scenario. And then each of the scenario, we use this counter, right? See whether, because she's guessing a G, that's the shell at the position G is a 1 or 0. If this is a 1, that means she is guessing correctly. Then we record this counter. If this shell at POS is 0, right? You remember this is just 1 and 0. Keep track. 1 is the position that has the pebble. 0, it doesn't have the pebble, right? So we, after the swap, we check whether this array has the pebble or not, based on the position that player guessing at G. And now we have those three counter, keep track those three scenarios value after we have played this n many times. So this we have recorded n many times, right? Then we use this max function, right? This array. So given this array, we checking those max value is the output. So any questions on this problem? The reason it's called simulation, right? This is the scenario, initial scenario, right? Each of them, right? We could put this loop here, right? So, but then you need to store this again. So this go through that, but it's better to put it inside this loop, right? This each time they play, so that we can keep track of all those three scenarios using three variables to keep track the score, right? We use an array of 3 to keep track the result of the 3 scenarios. Okay. I think that's all for today. Yeah. And so for those of you who have not done your homework, I do want to emphasize this. You need to practice, do your homework. If you encounter a question on the homework, feel free to post your question on the Google Classroom. Okay. Thank you.